In my time with SEMA, in my time with NHRA, and now in my time with SFI, the number one question that is always posed to me is, why in the world do I have to replace my seatbelts after just 2 years? Especially because I'm a sportsman racer, I got a business to run, I only run my car a half a dozen times a year, I keep it in a climate-controlled environment. I don't get it. Understandable. I understand perfectly well because I'm a Bonneville racer, and I bought a brand new set of 7-way driver restraints 2 years ago to put in my car, and Bonneville for the last 2 years has been completely rained out. So I have a brand new, never ever used 7-way restraint system in my car that is no longer certifiable. I get it. I understand where people are coming from. What I'm not sure that people understand is that this standard has to apply to the worst case scenario. Not the Bonneville car that's sitting in the garage for 2 years and never saw the light of day, literally, but maybe for the sprint car guy that runs 3 or 4 nights a week, puts the car through the car wash after every race, hoses everything off, including the restraint system, puts the car in the trailer, gets up early the next morning at the motel, unloads the car, and works in the hot sun all day long until they're ready to go to the racetrack and do it all over again. Now that may not be even the worst case scenario, but that's a typical example of the kind of abuse that these systems get, and so we have to understand that the standard has to apply equally to that environment as well as it does to my environment, in which I've got what I consider to be a relatively safe, manageable, serviceable set of restraints. Even with that said, my restraint system, I know now because of the science, having sat in that car in the garage for 2 years and having never been used, has lost a significant portion of its strength because of the nature of the material with which those systems are built. They're built out of either nylon or polyester, and those are synthetic properties that lose strength over a period of time, and that loss of strength is accelerated significantly when it's exposed to either UV rays, moisture, or both. So, I know that you guys who are out in the field dealing with the weekly racer, the ET guy, whatever, that isn't spending Don Schumacher's millions of dollars a year and could care less how often he has to replace his belts. You are the people, I know for sure because I've been there, are the people who are taking the heat from the guy to whom replacing something he doesn't need to replace in his mind is a problem, and he's going to take it up with you. I know from the NHRA perspective that a lot of you simply refer it to NHRA headquarters, and that's where I took the heat when I was running the department. And then we did a nice thing, and we referred everybody to SFI. Well, guess where I am now? What I want to do today is I want to help you all understand why the standard is what it is, and to help you be able to explain to your participants why it is the way it is, and also be able to refer them to an internet website where they can look up the scientific data that supports the 2-year requirement. And by the way, from the time that 16.1, which was the original driver restraint system spec, was developed, the certification period has always been 2 years. It's never changed. The science that resulted in the 2-year recertification cycle originally was minimal. The science supporting that decision now is extensive. And I want to show a little bit of it to you today and tell you where you can find it if you want to look at it again. We started with one spec, 16.1, that's the one most of you are familiar with. It was essentially a 3-inch webbing nylon system with a 2-inch or thereabouts anti-submarine strap. Since that time, we've developed 3 more specifications that are dedicated to specific motorsport disciplines. 16.2 is for youth assemblies, essentially a 2-inch unit with a much lower requirement for a pull test. 16.5, which is a stock car spec that was originally developed for NASCAR for their Cup series and their touring truck and other series. And now 16.6, which is an improvement on the 16.5 spec that was developed in conjunction with NASCAR at their research laboratory and research center in North Carolina. One of the wonderful things about SFI's relationship with NASCAR is that even though NASCAR was very late to come to SFI because of their culture, which was a sentence in the rule book that said safety is the responsibility of the driver or the participant, to where it is now, where NASCAR uses more SFI specs than any other sanctioning body, including NHRA. After the Dale Earnhardt incident, NASCAR spent $100 million building a research and development center in Concord, North Carolina. That corresponded with when they came on board as an SFI member sanctioning body, and we've been working in conjunction with those people ever since. So we've made our test laboratory available to them, and they've made their resources at the research center available to us. And trust me when I tell you, we don't have a $100 million research and development center. And it's nice to have access to an organization that does, and that is not only willing but anxious to work with us to achieve the highest possible level of safety for the participants, the track workers, and the spectators. You'll notice that there are two indications of labels that appear on a 16 series driver restraint system. The original, which is referred to here as the current design. The new label design for 2015, which has been in effect all of this year. The improvement of that being that we actually say valid 2 years from the date punched out or the actual date of manufacture. The original tag didn't say that, so unless somebody was familiar with the rule book and knew that there was a 2-year recertification cycle, the punched out date didn't really mean a whole lot to them. So this was an attempt to make sure that the tech inspector and the participant understood clearly that 2 years from the punched out date, that system required recertification, which consists either of rewebbing by the original manufacturer or replacement of the entire system, and a lot of that has to do with either the manufacturer's or the racer's preferences. Just yesterday we held our biannual committee meeting of the Driver Restraint System Committee to review these series of 4 specs, and starting in 2016, we will have yet another new label that will go on those systems that we think will eliminate a lot of misconception and a lot of confusion. The new label will simply say, this system is valid until, and it will have the date printed right on the label. The manufacturer will attach that label when he manufactures the product, and when it goes out into the field, no matter where it goes or how it's used, on the date that it says on the label, it will require recertification. And we think that will not only help tech inspectors, but it will help consumers understand we don't have to figure out, well, what was the date of manufacture, and when is it good to the end of that year or what month. And the bottom line is, the label is going to say exactly when it requires recertification. And we thought that might be a bit of a hard sell to the manufacturers yesterday, and it wasn't. And we were absolutely shocked and surprised that they were unanimously in favor of going to that system to eliminate any confusion and eliminate any possibility of somebody mutilating a label or something that would make it difficult to determine in the tech line exactly when that system needs to be recertified. Sure.
Do all other sanctioning bodies have, does everyone use a 2-year time frame, or does anyone use a 5 year?
The only other entity in the world that doesn't have a 2-year recertification cycle is the FIA, the International Automobile Federation. They have a 5-year recertification cycle. And a lot of people say, well, FIA, that's worldwide, that's a big organization with a lot of resources. They must know a lot more about this than SFI does. Or let me clarify, not SFI, the committee that the SFI organized to create this standard. SFI doesn't create standards. The committees that are developed in accordance with the U.S. government regulations for the establishment of accepted industry-wide standards calls for SFI to administer the process by which the committee develops the standard. When several of the sanctioning organizations that allow the use of either SFI or FIA certified belts came to us with the question, how come 5 years here and 2 years here? We show them our data and they go, okay, that makes sense. Well, where's the FIA data? There is none. There is no data to support a 5-year recertification cycle, and I served for 13 years as the president of the FIA Drag Racing Commission, and I can tell you from being directly involved with FIA staff, management, and technical department, when I asked them as president of one of their commissions what the supporting data was for their 5-year recertification cycle, their answer was there is none. If you understand that the FIA only sanctions absolute elite level motorsports, Formula One, World Rally Championship, that kind of stuff, none of those teams run those restraint systems for 5 years. Most of those teams replace all of their systems annually, if not more often. You will not find a Formula One car with a driver restraint system that's 5 years old. I can guarantee it because I look in them myself and I understand exactly how that works. Every other standard making organization, every other motorsport sanctioning organization worldwide accepts and adopts the 2-year recertification cycle. Some of them just because that's the way it is, some of them because they've had their technical people look at the data, and the data supports it, as I hope to show you. SFI specs state the useful life of the webbing and the strap shall not exceed 2 years, and they must be replaced at or before that time. Only the original manufacturer can re-web an assembly prior to recertification. Why? Degradation of webbing strength over time due to environmental exposure and concerns for safety. Process. Racers contact the manufacturer of their seatbelt assembly for recertification. For cost effectiveness, some seatbelt manufacturers choose to complete replacement of the harness rather than re-webbing it. And that's up to the manufacturer. Roughly half of the manufacturers are happy to re-web your belts. The other half will take your old belts in exchange, give you a discount on a new set. It costs about $69 to buy a brand new set of 16.1 certified assemblies. It costs about $55 to have it re-webbed and recertified. If you do the math, you can see that buying a new set a lot of times is just a heck of a lot more cost effective because you eliminate shipping costs. And even though we know the hardware is going to be serviceable for a significant period of time, the webbing isn't. So a lot of racers that maybe have their manufacturer in the same town, they can run it by, pick it up a couple of days later after it's been re-webbed. That might make a lot of sense. But if you don't have that, you got to ship parts around, you're probably better off just to go out and buy a new set or ship your old set back. And most of the manufacturers will give you a significant discount on an exchange of an old set of restraints for a new set of restraints. Seatbelt certification. What is the 2-year cycle based on? These are two charts that show very clearly the deterioration level of nylon and polyester webbing over a period of time. The first two charts that we have up here are the DuPont light and weather testing, which was in April of 1966, and that was the first time that we know that anybody actually tested the degradation of material over a period of time, and it was done by the actual manufacturer. DuPont at that time was pretty much the sole manufacturer of nylon webbing used in these systems, and most of their experience came with military applications, and it was actually the military that asked them to provide some empirical data, and this is what they provided them with. By 1993, the U.S. Army decided to do some outdoor weather and sunlight testing of its own to verify the DuPont research, and found that the deterioration factor was actually more significant than it was even in the DuPont testing. And as you can see, literally from the time that the product is produced, it's starting to lose its effectiveness, and it loses more of it over time, especially if it's exposed to UV rays and or moisture or both. How do we test for UV exposure? My boss at SFI, Arnie Coons, licensed engineer, MBA, pretty smart guy, didn't know how he could best measure the deterioration of webbing due to exposure to the elements. So being a scientist himself, he figured out that by stringing up some nylon webbing on the roof of the SFI test lab in Escondido, California, and leaving it there for a year or two, he could probably do some pull tests then and determine, exactly what it was. The only problem with that was any new material that came in for review and testing, had to sit on the roof for a minimum of a year, or more like 2 years, before there could be any realistic determination of what the deterioration factor was. Ultimately, a company came up with a marvelous machine that speeds up the process of exposure scientifically and measurably in a computerized situation, where we can put some material into this exposure testing machine and set all the dials and buttons and switches and whatever to whatever criteria that we feel is appropriate that we're looking for, and it will impose those forces on that material in a very compressed period of time, and then we can do the extrapolation of the exposure levels versus the pull test that we do on the material afterwards. And you can not only feel the difference in the material that's been exposed in this machine, you can actually see it. And not every form of nylon is going to discolor the way that particular one did. Some are more, some are less, and it depends on the quality of the dye and the material. But the material changes due to exposure. Now, this machine exposes not only to UV rays, but also to moisture, and it does both at the same time. So it's producing that worst case scenario that I was talking about before, and it does it in a very scientific and measurable fashion. Seatbelt recertification based on scientific data. Now, some of the numbers that you see here aren't going to make a lot of sense because of the way the tests are conducted, but essentially the spec requires that the entire system sustain 6,300 pounds of force on the body block in order to pass the test. That means that each piece of that material, including the 2-inch anti-submarine strap, has to collectively withstand 6,300 pounds of pressure. You can see very quickly that new nylon, which we call the control nylon, 10,000 pounds of pressure, well above the minimum. Poly, right in the same range. Once the material has been subjected to to the UV rays and the moisture and the retest is done, those numbers drop significantly to where nylon, on the average, falls below the 6,300 pound minimum level. The whole idea of 16.1 is to make sure that the restraint that's purchased new meets or exceeds the spec, but that it also meets that specification, meets that requirement at the end of its useful life, or the 2 years. And you can see that it's very close in the case of nylon to not even coming up to that standard. Again, this is worst case scenario exposure, so under average conditions, after 2 years, all 16.1 systems will meet that 6,300 psi requirement. The next one is simply the difference between 3-inch webbing and 2-inch webbing. And a lot of systems now that you're seeing in the tech lines are what we call hybrids. Some sanctioning bodies, and I think maybe the NHRA, still require minimum 3-inch webbing. The spec doesn't care, really. There is no requirement in the SFI 16.1 or the 16 series specs for 3-inch or any other width. It's strictly the strength requirement. And some of the improved materials, we find that the 2-inch belts meet or exceed the same pull requirements as 3-inch material, simply because it's heavier, it's thicker, and it meets. And biomechanically, a 2-inch system in many cases is actually more effective on the human body than a 3-inch system. Another thing that came into play was the hybrid system, which is where you have a head and neck restraint, and the restraint is not designed to accommodate a 3-inch shoulder strap, but it is designed to accept a 2-inch strap. And you'll see systems come through tech now where the shoulder harnesses are 2-inch, or at least in the area where they pass over the head and neck restraint device, but the lap belt will still be a 3-inch belt, and maybe even the lower part of the shoulder harness will as well. But we do have systems that are entirely 2-inch, lap, shoulder harness, anti-submarine, that are 2-inch, that readily pass 16.1, and many sanctioning organizations accept them readily. And biomechanical engineers like Dr. John Melvin will tell you that the body actually likes a 2-inch system in some cases, or in a lot of cases, better than a 3-inch system. So you're gonna, it used to be you saw all of the same stuff come through the tech line. It was all 3-inch, it was all 16.1. It's not that way anymore, and it's important for you to understand that what you're looking at is going to be a different kind of system than you may have seen over the past few years. But the important thing is, if you see the SFI label on it, and now you'll see the actual expiration date, all you want to do is make sure that that system is within the certification range, and you can have total confidence that that driver is going to remain in the cockpit where he belongs. Another issue that comes up in the testing is something called dumping. Dumping is simply the phenomenon where the webbing is attached to the adjusters, and all systems have adjusters. You got to pull your belt's tight. And what happens is, if the installation is incorrect and there's a misalignment between the two areas of the webbing, when the webbing undergoes a significant impact and a significant pull, the webbing will pull to one side of the adjuster, and it significantly reduces the effectiveness of the webbing. So the reason that we like to emphasize that with technical people is that your job is not only to verify that the tags are on there and the system is within the certification cycle, also that it hasn't got visible damage, cuts, burns, things that obviously would cause them to be decertified. But you also need to look at the installation, and if you see a lot of misalignment between parts of the system, you might want to suggest to the racer that they get together with the manufacturer or the chassis builder or whoever and take a look at the way things are done, and make sure that when there's an impact, whether it be frontal, top, side, or whatever, that all of those sections of the system remain as well aligned as possible. So those are some things that you want to look for. And again, we have the numbers that show what kind of deterioration in performance that we get in the dumping situation. Now, what kind of testing we do for certification to the 16 series specs is done on what we call a body block. It's a wooden block that mimics the human form, and it's the restraint system is draped over the body block, attached to hydraulic rams that are calculated to apply a certain amount of pressure to the entire system at one time. And it pulls on all 5 or 6 or 7 of the elements of the system at the same time, pulls it to the required 6,300 pounds and stops. We do not test these systems to destruction. So when people come to us and they ask me all the time because they know I'm involved with SFI, well, what's the best one? I want the best one, the strongest one that money will buy. We don't know. We really don't know because we only test to the spec. We don't test to destruction. We want to just make sure that the system that's labeled and certified meets the minimum standard, because we know over years and years of experience in all kinds of racing applications that the standards that are required to be met by the spec are capable of keeping the driver in the car where he belongs. And that's all we're trying to accomplish. One other thing that we do, though, is we use some other kinds of testing to try to verify that the kind of testing we're doing on the body block is actually correlated to maybe some other kinds of testing that can be done. When we test for head and neck restraints, the test is what was called a sled test, where in the test lab they fire a sled with a dummy mounted that's instrumented completely, and the systems are completely instrumented. Everything is measured, and they apply G-forces that would simulate a frontal impact, and then they measure how everything performed. And this is an example of the numbers that we received off of a sled test that we did for head and neck restraints. And when you see numbers like 14,000, you think, oh my God, that's way above the test spec. Well, those are joules, which is an engineering term. That's really 3,200 pounds of pressure that's exerted on that driver restraint system in that frontal impact. And it absolutely correlates directly to the numbers that we see on the body block. So it helps us to verify that the numbers that we're dealing with are correct and verifiable. The next recertification thing here talks about 3,200 pounds of force, which is similar to what we had on the sled test, and it shows the deterioration of performance when dumping occurs. And this relates right back to the installation issue that I talked to before. If the system is not installed correctly and you experience dumping, those numbers drop down into the 2,500 pound range, 2,600 pound range, which is only about a third of the required strength of the system according to the spec. So it just re-emphasizes the importance of proper installation. Seatbelt recertification, other considerations. Certifications are not valid beyond the expiration date set by the standard. Allowing use past expiration is a liability risk. Let me talk real quickly about liability risks. I spent 9 years at the NHRA as Vice President of Safety, Insurance, and Legal. The least number of lawsuits that NHRA defended during those 9 years that I held that position, the least number was 21. NHRA is a huge litigation target because of what we do. Now, not all of those were drivers involved in crashes. They were drunks falling out of the grandstands, people tripping in the parking lot. I mean, there were, but suffice to say that we live in a very litigious society. SFI has developed 2 programs that are designed to protect the sanctioning body and the individual tech inspectors from liability exposure. One of them is the minimum standards. If you make sure that all of the products on the car that are required to meet minimum standards as required by the rule book, as an inspector, you are virtually liability free. The sanctioning body is also liability free. But in the worst case scenario, somebody crashes. There's a post-incident investigation done. The family hires an attorney. The attorney hires an expert to do his own examination. First thing he determines, well, the driver restraint system was out of the certification cycle. It was illegal for use. That constitutes improper inspection, which results in something called strict liability. You as an individual are liable, the sanctioning body is liable, the track is liable, everybody's liable except the manufacturer, because he did everything he was supposed to do, and he's going to point his finger at everybody else to avoid the liability exposure. So, you know, when I took over the NHRA tech department, there was kind of an unwritten, unspoken policy that, well, if something is beyond certification cycle or not exactly right, we'll give you a 1 or 2 race reprieve, but don't bring it back until it's proper. I did away with that. At the events that I had direct influence over, which were NHRA national and divisional events, I said, we don't make exceptions like that. What we will do, what I insist that you do as a technical inspector, is to make sure you do everything you can to help that racer comply with the requirement. And if that means calling somebody you know, or telling a guy where the local speed shop is, or help him make a phone call to a supplier somewhere that can get the proper equipment there as quickly as possible, do that for sure, and do everything you can to make sure that it's possible for that racer to comply and then go out and race, and then you're covered. If there is no replacement available, do you send a guy home? Well, the tech guy probably says yes, and the track operator probably says no. But make sure if the track operator says no that you got it on a recorder, or you make him sign something, because otherwise the tech inspector is going to take a lot of heat. And at the very least is going to have to justify why he made an exception to a written safety-related rule. So be very conscious of liability exposure, because it can bite really hard. Subjective interpretations by tech inspectors must be minimized to reduce the liability they incur personally as well as track and sanctioning body. It's difficult to reject equipment based on its condition or visual appearance versus meeting an objective specification or date. That means that no tech inspector should be charged with the responsibility of simply looking at a driver restraint system and saying, yeah, it looks pretty good to me. Make sure it's in the recertification cycle. What it doesn't mean is, if you see that there's a cut or a tear or a burn in that system, or that the installation is incorrect, or the hardware involved in the installation is correct, that you shouldn't reject the system and require it to be brought up to spec, because that's part of your job as well. Simply seeing the tag isn't enough. You need to do the entire job, which is to make sure that every aspect of the installation and the product is correct. Other considerations. Webbing strength deterioration can be invisible, and this is what I talked to a little bit before in our UV box. These are 3 different examples of webbing that we have tested in our environmental box, or subjected to the environmental situation. They all are virtually identical in performance, but completely different in appearance, and it all has to do with the quality of the die. So you cannot look at a system and, because it's jet black, assume that it's brand new or it's serviceable. Doesn't mean anything other than the fact that it's probably a little bit prettier than the one that turned gray. Other sources and studies on webbing strength and UV exposure: National Transportation Safety Board, Web Sling and Tie Down Association, U.S. Army, Celanese Corporation, DuPont. All of these are tests that have been done by various governmental agencies and manufacturers and military organizations, and we include them because they absolutely mimic everything that we've seen as far back as the DuPont 1966 tests. It's the product of nylon webbing is what it is. It hasn't changed much in the last 50 or 60 years. It's not likely to change much. We get a question a lot of times about in our testing, what's better, nylon or polyester? They have different qualities. Some nylon performs better in some ways, polyester in other ways. Nylon slips less in an adjuster than polyester, but polyester degrades slower than nylon. They both, after a 2-year period, end up at about the same strength level. It's just that the nylon drops off in strength faster than polyester, and that's why a lot of racers have been convinced by manufacturers that polyester is actually a better option. And sometimes it is. Sometimes it's not. The important thing is they're both certified to the same level of testing, same minimum requirements, and it's really up to the consumer, the racer, to determine what's best for his application. As long as it's in the certification period and it's undamaged, it shouldn't make any difference to you one way or the other. Last but not least, if you ever have any questions or comments or observations, you know, we at SFI live for information, for input. We're a very small organization. I mentioned before, we're 9 people. And that includes the people that run our test lab. We do a lot of work with very few resources, but we do it as a nonprofit foundation, simply because everybody that's involved with SFI is dedicated 100% to motorsport safety. It's what they get up every morning wanting to do. It's the only reason we exist. If you have a racer that you try to explain some of this to in the tech line in general principles, and he's really upset because his system is perhaps out of certification cycle, maybe not by much, maybe by a whole lot, but he thinks in his own mind, he's convinced that it's perfectly safe and he can't understand why you're not going to let him run or you're going to make him replace the system. You can try to explain some of what I've presented here, but if it doesn't register, refer them to the SFI website, www.sfifoundation.com. And at the home page on the website, there's a subsection called Guidelines and Bulletins. And this very same presentation on PowerPoint that I've just made to you this morning is there for anybody to look at anytime, 24 hours a day, 365 days a year. For your own edification, something that I won't take the time to talk about today, there's a lot of information about driver protective clothing. There's a new one about protective underwear, fire-resistant underwear, and what impact it has on the performance of driver protective clothing, and how far it will exceed the minimum requirements by the 32A specifications and things like that. It'll explain a lot to the racer as well as to yourselves about why nobody should ever go down a drag strip in a vehicle that's required to wear fire protective clothing and not wear FR underwear as well as the required oversuit. And there's a lot more information there as well. So it's a resource that we make available to you as technical inspectors and to consumers and manufacturers. And we're trying to upgrade the website all the time, and we're constantly trying to explain the rationale behind what we do and why we do it and why things are the way they are. And if there's any suggestions that any of you ever have as to how that can be improved or how we might be able to do some other kind of presentation that will help you explain to your racers why things are the way they are, please don't hesitate to contact us. All I can say is thank you so much for your attention. I hope you appreciate what we've tried to explain here. And I hope that when you go forth in 2016 to your various tracks and conduct technical inspection, that maybe you'll have a little better understanding of why things are the way they are, and when you get beat up about the 2-year recertification cycle, you can at least know in your own mind why it is, and you can tell the racer where he can find out more information for himself. And thank you very much.